Hi and welcome to the video tutorial about how to use plug and play Control Toolbox. This tutorial is about how to use demo version of that program, so you'll be able to use just the simulation feature without any real devices. So my name is Martin Blazinšek and I come from University of Ljubljana, Faculty of Electrical Engineering, and let's just start our tutorial. PPCT, at the beginning PPCT has some language options, so let's choose English as I speak English. So for introduction I would like to present you first how the graphical user interface, how it's put it together. So it has, as you can see, 3 columns. In first column we should choose initial values about our test, so test time, sampling time, set point, and the others. We can also choose between device in full version, and also this is for real devices connection, but as I said, in this demo version you won't be able to use this feature, so our focus is on the simulation. For the simulation we have to choose the model on which we will be doing our tests. Then we can choose between different identification methods, and in the last step we can choose between among several controllers. So the middle column, the second column, is for presenting what is going on with our test. So here in the graph you'll see all the needed signals, like a set point signal, input signal, output, error, and the last checkbox is just for graph scrolling, so you won't need this feature. So below the graph here are some buttons. Start button is for starting the test, then stop test. We can clear the graph, and the last button actually refers to the results. It's refreshing the results displaying, because I have some problem with displaying results which are actually calculated correctly, but so in full version this bug will be removed. So if you won't see any results here at any time, you should just refresh the whole interface. Sorry. So below those buttons here is a progress bar, and then 2 boxes. One is with current values like input, output value, and the right one is here you can read the algorithm recipe. So the last column represents results. Here you can see the working point of our test, the noise, input noise and output noise. Here can be model parameters, identified model parameters seen. Tau1 represents first order time constant. Tau2 represents second order time constants, like multiplied second order time constant. K stands for gain, model gain, and D stands for delay time of in the identified model. Below those parameters, here are some parameters for some identification parameters of relay feedback identification method, like swing period, ultimate gain, ultimate frequency, and amplitude of the swings. And the most interesting parameters are identified PID controller parameters like proportional gain, integrating time, and differential time. And below them here can be seen control quality parameters for reference tracking and disturbance response. OS stands for overshot, and here is settling time 5% criteria, and also some other integrating costs like integrating square error and the others. So if we start at the beginning, first we have to choose the test time. I recommend 500 seconds, even though the most of the experiments last less than 100 seconds, but we have to pay attention when we'll be choosing higher order models with longer time constants. We have to choose like longer test time. Then here is a sampling time. For most models, 50 milliseconds will work fine, but we can also choose higher or lower sampling time, but not higher than 100 milliseconds. Then we can choose speed of the simulation from 1 to 16 times, but 4 is just fine. But what is slower than 4, you'll get bored because the simulation will be really slow. So next step is to set the set point at relay feedback or input operating point at DMC. After the identification, in the end of the every identification, the test of the identified parameters is started. So here we can choose the step, the difference in step response, and also the step at the input of the process, the amplitude of the step for the disturbance. And now we'll choose just the model parameters. Here we can choose actually between 1 to, I don't know, to infinity order, but let's just focus to first order model. Here we can set the tau, which is time constant, and we will leave 1 second. This is a dead time of the process, so I'll choose, I don't know, 0.16 second. The next parameter of the model is gain. I'll leave 2, and the last parameter is noise. This is a relative number, so 0.010. It's quite enough of noise. And here this numeric up and down is for using. Here we can also choose the integrating process, but our focus will be on proportional stable systems. After we have chosen all of that parameters, below them we can see the transfer function of the chosen system. So this is all about the model, and now we can go to the next step. We can choose identification method. For every test, we first have to set the settling parameters. I won't the background of that parameters isn't important at that time. So I'll just have to say that if you if you choose the higher number of that parameters, the algorithm will detect the stability of the system later, and if you choose lower numbers of those parameters, the stability of the system will be detected sooner. But if you choose numbers which are too low, then like the program will detect that the system is stable, even though it won't be. So I recommend to choose this exp parameter between 3 and 6. For our case, I'll choose 3, and counter should be like between, I don't know, 3 and maybe 10, and for our case I'll choose 5. So now we have just to select the identification method. In this demo version we can choose between relay feedback and step response identification method, and I'll choose relay feedback. And now at relay feedback we have to choose we have to set 2 more parameters, which are hysteresis of relay and number of swings. Number of swings, like 5 swings for identification of the process at that method, it's quite enough, but our focus is on hysteresis, because if we choose here at the beginning higher set point, or higher set point, then we also have to higher the hysteresis of relay, but like for set points, I don't know, from 1 to maybe 6, this number is quite good. But you'll see that when you making your own test, that how it works. But yeah, I have to point out that in a full version, you won't have trouble with that, because like this hysteresis is adjusted automatically. So what are you waiting for? Get a full version of the PPCT. Okay, our last step is controller selection. So I have to say that I don't know if I have said that before. So the relay feedback will work for all of the controllers except for DMC. As you have seen before, that DMC has its own identification method. So for relay feedback, I'll choose PID, the ordinary PID controller, and I'll just start the test. So here we go. Here at that point you can see like the stability was detected, and then the relay was turned on, and then the controller was switched on, and here from, I don't know, 28 second to the end, the last test was started. At the beginning we can see that the system has a really low overshot, and also the disturbance response is quite good. And why we can see that, if we press the refresh button, we can see like the overshot is less than 6%, and including noise. And here are also other criteria which describes that our identified parameters worked fine. So here is a recipe of our test, and I think this is it. If you have some further questions, please address them to my email. Help is unfortunately still under construction, so for the beginning, the first step is to write me on that email, and what I can say in the end, that thank you for your attention, and I hope you enjoyed the plug and play Control Toolbox tutorial for demo version. So see you next time.